Hey guys, this video will take up one more example on finding convolution sum of an infinite length sequence. So it's better I just solve it in a one single video. In case if it takes longer duration, please have patience and look at step by step. Okay. So the example here is find convolution sum of x of n is 2 power n u of minus n and h of n is u of n, right? I have already solved three problems on convolution sum of an infinite length sequence. I hope somehow you got used to it, but still I will try to go in deep and I'll try to take solve this problem. Fine. Okay. Solution. What is the first step? First step is to plot the input signal x of n and the impulse response h of minus n. I need to plot h of minus n, not h of n. Okay. Uh, how does an x of n signal looks like? I'll try to put it in a separate sheet. So x of n is what? 2 power n u of minus n, right? So how does this signal looks like? So it is combination of two signals, right? 2 power n multiplied with u of minus n. So we'll plot separately and we'll see how does it looks like. How does a 2 power n signal looks like? So it is varying from minus infinity to plus infinity, so till minus infinity, and this is 1 2 3, this goes to plus infinity. So when n equal to 0, 2 to power 0, which is 1, right? So when n equal to 1, it is 2 power 1, which is 2. When n equal to 2, it is 2 to the power 2, which is 4, and it goes on, right? When n equal to 3, it is 2 to the power 3, 2 to the power 4, 2 to the power 5, it goes on. And when n equal to minus 1, it is 2 power minus 1, which is 0.5. When n equal to minus 2, which is 2 power 0.2, which is 0.125, 0.25, right? And here it is 0.125, and again this goes till minus infinity. Okay, and this signal is multiplied with what? U of minus n, right? How does a u of minus n looks like? It is nothing but u of n mirror image, u of n's mirror image. So this is our u of n, 0 1 2 3 4 5, which amplitude is 1. If what is u of minus n, I have to take its mirror image, right? All the positive amplitude comes to negative. Fine. So this is our u of minus n signal, which amplitude is 1. Okay. So when I multiply these two, what happens? So I get x of n, right, which is 2 power n u of minus n. Now when I in the positive side, when n equal to 1 2 3, 1 2 3 4 dot dot dot, the amplitude is 0. 0 multiplied by any signal is 0. So therefore, so for n varying from 1 2 3 4 till infinity, I get 0, right? So 0 multiplied by any signal is 0. But whereas in the negative side, the signal is 1 times the sample is, I get the same sample 1. At n equal to minus 1, 1 times this is 0.5. At n equal to minus 2, 1 times this is 0.25. At n equal to minus 3, so this is minus 3 minus 4, 0.125, and this goes till minus infinity, right? So this is the signal x of n, which is 2 power n u of minus n, which looks something like this. It's exponentially increasing, right, from minus infinity. So 0 minus 1 minus 2 minus 3 minus 4, and these are all the samples. This one, right? I hope this is convincing. Now I'll plot x of n sequence, x of n. Now how does an x of n looks like? X of n is like this, right? It is 1 at n equal to 0, and it is an exponentially increasing from minus infinity. This is 0, this is minus 1, this is minus 2, this is minus 3, this is minus 4, this is minus 5, it goes on, fine, which is 2 power n u of minus n. Now how does an impulse response looks like? So impulse response is just unit step function. So it is starting from 0 till infinity, its amplitude is 1. Its amplitude is 1. Okay. Now what I need to do, I need to replace its independent variable to k. So x of k, this becomes k. This is h of I'm sorry, I have to take, actually this is, let it be n, and I have to take the mirror image of h of n, which is like this. And this goes till minus infinity, right? So this is 0, minus 1, minus 2, minus 3, minus 4, minus 5. This is h of minus 1. So amplitude is 1. So now I need to replace its independent variable to k, right? Fine. Now I have the sequence as per the formula of convolution sum, right? What is the formula of convolution sum? Y of n is equal to summation k varying from minus infinity to infinity x of k h of n minus k, right? I have x of k and I have h of minus k, but n is, it is there in the formula. We'll see that. Okay, fine. What is the next step? This is step number 1. What's the next step? Step number 2. I have to bring step 2. I have to bring both x of k and h of minus k in a same variable k, independent variable k, right? So 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, so till minus infinity to plus infinity. So first I need to place x of k sequence, which is like this. Right? What is this amplitude? This is 1, this is 0 0.5, 0 0.25, 0 0.125, and goes on, right? So x of k doesn't move, it remains in that position. Whereas what about h of minus k? So h of minus k is also from 0, I mean from minus infinity up to 0. Now if I bring this signal and if I keep it in the same position, I hope you can imagine how does it looks like, right? So I'll put it in, it's like this. I'll just put just here. Okay, so this is my, I'm writing the samples just above the x of k sample so that you can distinguish which is x of k and which is h of minus k. Okay, so this is h of minus k sequence, and this is this sequence, and this sequence is x of k sequence. So I did not overlap the samples because you can, if I overlap it, it might be a confusing for you. You cannot see what's happening. So I just wrote the samples just after the first sequence, which is x of k. Okay, so this is x of k, which is nothing but 2 power n u of minus n, and this is h of minus k, which is nothing but u of minus n. Okay, I mean you got, fine. What is the next step? So I need to decide the slider, right? So where does my slider is actually the impulse response. The other end, one end is minus infinity, which I cannot reach, but the other end is 0, which is here. This is my slider. And what is the slider index? It is actually at 0, so it is just n. If it was in 4, if this sequence is at 4, then it could be it was supposed to be n plus 4. If this is somewhere at minus 2, it would be like n minus 2, which we have done it in previous problems, right? Since it is 0, now it is just n. Now since I placed the slider here, now I can move this slider from when I say I can move this slider is nothing but I can move this h of minus k sequence, right? I can move this slider from minus infinity to infinity, and I have to uh, uh, come up with like non-overlap regions and overlap regions. This is a case, this is a kind of problems where we won't get the non-overlapping region. So wherever you move this slider, the h of minus k sequence from minus infinity to plus infinity, there will be a overlapping of the two sequence, which is x of k and h of minus k. Okay, so I'll show you. I'll show you with a cartoon sketch of those two sequences. So this is x of k sequence, x of k sequence, and if I start my h of minus k sequence from minus infinity, there will be a overlap of x of k and h of minus k, right? So for example, you assume that I started from minus infinity and keep on moving to 0, say minus infinity dot 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 up to minus 1000. Say this is at n is equal to minus 1000. If I bought that h of minus k sequence at n is equal to sorry, k is equal to minus 1000, this is how the sequence looks, right? And what is the overlap portion? Overlap portion is this, where it started, the overlap started at minus infinity itself, okay, and it ended at n, and I kept this n at minus 1000, right? Now if I move right further, say if I keep it to minus 10 somewhere here, this is minus 10, this is n, this is k, right? This is k. What is the overlap portion? It started from minus infinity and it stopped at n, and where I kept my n, it is at minus 10, k equal to minus 10, right? Now if I still move it further right, so I move it at minus 1, so this is at n, and overlap portion is from minus infinity till minus 1, right? Say if I move it further right, say if I move it at 5, so this is 5 and this is n, this is k. Now tell me, what is the overlap region? It started from minus infinity and its ends at where? Ends at 0, right? So after 0, after the this is at 0, this is 0, and this is 0, right? After 0, when I move this h of minus k, and what is this? This is x of k. After 0, when I move this h of minus k to right anywhere I want, overlap portion remains same from minus infinity to 0. After this, till infinity, if I put this slider till infinity, overlap region remains at from minus infinity to 0. Okay, so this is what happening with respect to overlapping region of the sequence x of k and h of minus k. Fine. So from where to where? I mean to say from minus infinity to 0, from minus infinity to 0, overlap region equation for overlap region actually will vary depending upon where I keep this n. Okay, where I keep this n, till where? Till I move the slider from minus infinity to 0, overlap region will vary. Okay, whereas after 0, wherever you keep your slider till infinity, overlap region will be constant, it remains same. Fine. So there are two regions now. Region is from minus infinity to 0, and region is from 0 to plus infinity. Fine. So I hope it we got convinced. We come back to the problem. Now we'll have step 3. What is step 3? I need to move the h of minus k sequence from minus infinity to plus infinity, and I have to check for those overlap regions, right? Now say I will assume that this is x of k sequence 0. We'll assume that my h of minus k sequence is somewhere at okay, so it's -1. So this is at n, this is k. And what is the overlap region? It starts from minus infinity and ends at what? Depending upon where I keep n, right? And I have a boundary for this n, I cannot reach more than 0. I have to stay in between minus infinity to 0, because after when I reach when I move my slider further right after 0, the overlap portion will remain constant, right? So I need to decide from where to where overlap region will vary, and after what value of n overlap region will remain constant. I hope you got what I'm trying to say. So uh, n for n is what? Less than, for n less than or equal to even 0. When I keep this n at 0 also, the overlap region will, when n is less than or equal to 0, I will include 0 part. Okay, in the next region I will exclude this 0 part. So when n is less than or equal to 0, y of n is equal to summation k varying from minus infinity to infinity x of k h of n minus k. This is as per the convolution sum equation. Y of n is equal to summation k. What is the overlap region? From where it starts? It started from minus infinity, right? And where does it ends? It ends depending upon where I keep this n slider, right? Even I can, but there is a condition, I can keep till n equal to 0. So for k varying from minus infinity to n. Okay, and n has a condition, n should be less than or equal to 0. From minus infinity till 0, I can keep this n, right? X of k, right? What is x of n? X of n is 2 power n u of minus n. Anyhow, u of minus n is 1 everywhere. U of minus n sequence is 1 everywhere because it is unit step function. But we have u of n. So if x of n is 2 power n, what is x of k? It is nothing but 2 power k, right? So I'll write it as 2 power k. Fine. H of n minus k. So what is h of n? What is the amplitude of this? This is nothing but h of minus k. And it does not matter because it is 1 everywhere, no? So I'll just write it as 1. The amplitude of the input sequence, which is this, the amplitude of h of n minus k, the other sequence impulse response, which is 1 everywhere. Fine. Okay. Now this is a little bit lengthier. We need to simplify this. In order to simplify this, I need to bring this in a standard form. And what is that standard form? Standard form is summation n varying from 0 to infinity alpha power n. Okay. So the result is this. Result of this standard equation is this. Infinite series is 1 divided by 1 minus alpha, and the condition is magnitude of alpha should be less than 1. Okay. So somehow I need to bring this equation to this form. In the sense, lower limit should be 0, upper limit should be infinity. But here I have lower limit is minus infinity and upper limit is n. So we will do some mathematical operation and we'll bring this equation to this. Fine. So what is this? So this is summation k varying from minus infinity to n 2 power k. So what I'll do, I'll interchange this limits. So I can do that. So summation k varying from n to minus infinity 2 power k. So without any consequence, I can interchange the summation limit, right? Because if you sum it up from left hand side or you sum it up from right hand side, you get the same value, right? So I did that. Instead of summing it from minus infinity to n, I'm summing it from n to minus infinity. Okay, now I don't want this to be minus infinity, I want this to be plus infinity. So for that, what I'll do, this is actually k, right? So k is varying from n to minus infinity. So in order to bring this minus infinity to plus infinity, I'll put k is equal to minus k in this summation. So what do I get? Summation minus k is equal to n to minus k is equal to minus infinity 2 power minus k. Fine. So now what, I'll write it in terms of k. So what happens? Summation k is equal to, so this minus goes to the other side, minus n, and this minus minus cancels out, k is equal to infinity. Okay, so 2 power minus k. Fine. Now, as I told you in the problem 3, we simplified uh, uh, the equation in problem 3 the same way we are going to simplify here. So what I need here is 0. The lower limit should, I want the lower limit should be 0. In order to do that, what do? We just bring this to the left hand side and we equate it with a dummy variable, right? So we'll do that. So put so k, this minus n goes to the other side. So what happens? Plus n is equal to, I'll equate this with the dummy variable m, right? Fine. And I'll write this in terms of k. What is k from this? K is what, nothing but m minus n. Now in this equation, wherever k is there, I replace it by m minus n. Fine. So that what I'm trying to do here is I'm just trying to make this lower limit as 0. Okay. So what happens to this summation? So summation, so k, but instead of k I have to write m minus n is equal to minus n to m minus n. This k is equal to infinity. So 2 power minus of, and I have k, but I have to write k as m minus n. Fine. Now if I have to write this in terms of m, so if I take this minus n to the other side and minus 10 to the other side, what happens? So this is equal to summation m is equal to 0 to infinity. So m is equal to infinity plus n is infinity, minus n plus n is 0, and 2 power, I'll remove the bracket, minus m plus n. Fine. So summation m varying from 0 to infinity, if I split the power, 2 power minus m into 2 power n, and 2 power n is independent of m, I can take it outside, right? So this becomes summation 2 power n into summation m varying from 0 to infinity 2 power minus m. Now I have in the standard form something like summation n varying from 0 to infinity 2 power minus m, right? Even I can simplify this, 2 power n in times summation m varying from 0 to infinity, so 1 by 2 power m. I can write like this, no? Because 2 power minus m, I can write it as 2 power minus 1 whole power m, and 2 power minus 1 is 1 by 2, which I wrote it as 1 by 2. So this is the simplification I have done just to bring this to the standard form. Okay, so what I'll do, I'll write this as y of n is equal to, so I started from this equation, right, and I ended at this equation. So it is nothing but 2 power n into summation m varying from 0 to infinity 1 by 2 power m. Okay, so y of n is equal to 2 power n into, so what is the standard form? Summation n varying from 0 to infinity alpha power n is what? 1 divided by 1 minus alpha, and magnitude of alpha should be less than 1, this standard result. So this is nothing but 1 divided by 1 minus alpha is 1 by 2, right? And what is this? 2 power n into 1 divided by 1 minus 1 by 2 is 1 by 2, 1 divided by 1 by 2 is 2, right? And what is this? 2 power n plus 1. So y of n, the output is 2 power n plus 1 for n less than or equal to 0. Okay. Now, this is for n varying from minus infinity till 0. Now I have to move my n slider further right till infinity. Okay. So for that case, when I move the other sequence further right, so I keep it here somewhere 10. This is k. Overlap portion start from minus infinity and ends at 0. Wherever you move further right, it always ends at 0. Okay. So in this case, n is what? Greater than 0. I cannot put greater than or equal to 0 because I already equated it less than or equal to 0. Okay. So n is greater than 0. For that, what is my y of n? Y of n is summation k varying from minus infinity to infinity x of k h of n minus k. So y of n is equal to, so overlap portion start from minus infinity and ends at 0. X of k is what? 2 power k. Why? Because x of n is 2 power n, therefore x of k is 2 power k. And what is h of minus k? It is unit step function, it is 1. Okay, so this is equal to what? I can interchange the summation k varying from 0 to k is equal to minus infinity 2 power k. Now I have minus infinity here, I need to bring it to plus infinity. So what do I do? Put k is equal to minus k. So what happens to this summation? This is equal to minus k is equal to 0 to minus k is equal to minus infinity 2 power minus k. Now this minus goes to the other side, minus 0 is 0 and minus minus is plus. So summation k varying from 0 to infinity 2 power minus 1 whole power k, which is equal to summation k varying from 0 to infinity 1 by 2 power k. And what is this? 1 divided by 1 minus 1 by 2, right? And what is this? 1 by 2. So therefore y of n is equal to 1 by 2 for n greater than or equal to 0. Fine. So therefore, to sum it up, what is y of n? Y of n is equal to what? 2 power n plus 1 for n less than or equal to 0. 2 power n plus 1 for n less than or equal to 0, and it is 1 by 2 for n greater than 0. So this is the output of the system.